Okay, now let's move on to the question number 3 of our first worksheet. There we have to compute all sample points for R9, M3 and L4. First, let's see what do these symbols mean. Right, now what do we mean by R9? Here, the letter R stands for the meaning right. Okay, it stands for right, and this is for middle, and this is for left. Okay, so what do we mean by R9? Here, when you say R9, that means we are considering right endpoints of our interval. Now, in this specific example, we are asked to use the negative to 4 interval. So, instead of A and B, in the general example, we have negative 2 and 4. So, we have negative 2 here and 0 in the middle and 4 at the rightmost end. And then this 9 goes with the n in our example. In other words, we have to divide this interval into 9 equal parts. Now we are doing this one. So this 9 will give you the information that we have to divide this interval into 9 equal parts. Like this, we have to divide it into 9 equal parts. Equal parts in the sense 9 equal subintervals. Okay, now as we have read the number 9, as we understood the meaning of number 9, how does this word right comes into play? Here, when they ask to find the right sample points, that means we just have to mention all the right endpoints of these subintervals. Now, in the previous example, we have even calculated a general expression for the right subinterval, for the coordinate of the right subinterval. So we can even directly use this formula. Or in other words, if we would like to go from the scratch, we can start from negative 2 and we have to add this distance. So what should be the distance of a subinterval? How are we going to calculate the distance of a subinterval? By using this formula. Now you don't even have to remember by heart all these formulas. You can just come up with those simple formulas at that point itself, right? So what we have to do is we have to divide this length into 9 equal parts. So what is the distance between 4 and negative 2? We have to subtract the two numbers and then divide by 9. That means we have here negative times negative 2 is 6. 6 divided by 9 will be 2 over 3. So this is the length of a subinterval. And accordingly, what should be the value at this point? It will be negative 2 plus this distance. So that distance will be 2 over 3. Okay, then it will be negative 4 over 3. So this will be negative 4 over 3. And then how about this point? We should add 2 times of the subinterval distance into this one. Negative 2 plus 2 times 2 over 3 will be the value at here. And this one will be 3, 4, 5, 6, 7, 8. And the final, the last subinterval will be the 9th subinterval, right? So what will be the right endpoint of the ninth subinterval? There we should add 9 times of the interval length to -2. So -2 plus 9 times the subinterval length, which will be -2 plus, these will get cancelled out, 6, and that will be equal to 4. See, this is the rightmost endpoint of our main interval. So these two values should definitely tally each other, because this is our final subinterval, and the rightmost endpoint of our final subinterval should be the same as our initial big interval, because that is the interval that we are dividing. So this right endpoint of our last subinterval should be the same as the final endpoint of the big interval. So those two values match each other. Right. Then let's see what we mean by the M3. There, the only difference is, now when you say M3, M represents the middle and 3 represents that we have to divide the interval into 3 equal terms. And now this is our big interval. So we should divide the interval into 3 equal sub-intervals like this. And M3 represents the middle value of each interval, right? So now just by looking at the diagram, we can easily evaluate the values of these middle points. Now, first of all, what should be the distance of a subinterval? How are we going to calculate that? It comes from the same formula that we derived before. So the interval length is 4 minus 2 divided by 3. So that means what we have is, as before, 2 over 3. And this length will be 2 over 3, and accordingly this small portion will be the half of 2 over 3. So this length is 2 over 3. Since this is the middle point, this length will be the length of the subinterval divided by 2, which is 1 over 3. So this length will be 1 over 3, and if you need to calculate M1, that means the middle point of the first subinterval, that will be -2 plus 1 over 3. And if you need to calculate M3, what you have to do is you have to add 1, 2 and 3 times of these small segments. -2 plus 3 times those small segments. And well, I think I have made a mistake here. This is not 2 over 3, it should be 6 over 3. So altogether it will be 2, right? So this will be, the interval length will be 2, and divided by half will be 1. So this small portion will be 1. Sorry, it is not half, it will be 1. So this point will be -2 plus 1. This point will be -2, 1, 2 times of this small length, which is 2 times of those small lengths, and likewise you can easily compute the middle points of these subintervals. And then we need to compute L4. So it has the same nature, but instead we should calculate the left end points of the interval divided into 4 equal parts. So we have the big interval, -2 to 4, and we should divide everything into 4 equal parts, right? And then we have to compute the left endpoint of each sub-interval. Simply, we should start with -2, which is our initial starting point of the main interval, right? So the first will be -2, and then what will be the interval length? -2 minus 4 -2 divided by 4, right? And that will be 6/4, which is 3/2. And then in order to calculate the left end point of the second subinterval, or in other words, this is the right end point of the first subinterval. That is also correct. Okay. So accordingly, we can find out the left end points of these subintervals. For example, if we need to calculate this one, starting from -2, we should travel 2 times the distance of a subinterval, which is plus 2 times 3/2. Likewise, we can complete the first worksheet.